Welcome everyone to our continuation on the series of the topic of friction, and this topic comes under the chapter of laws of motion. So, like in the previous video, we were covering the ideas of static friction and basically some introductory ideas to friction. So, what was static friction? So, as you would have remembered, we drew this particular graph. That there is a graph like this. That this is the force of friction F. On the horizontal axis we had the applied force F, capital F, and we concluded that the force of friction, it grows linearly with the applied force up till a point, and that point or that limit up till which the force of friction goes to is actually called limiting friction. And now beyond this point the motion would start, and the different type of friction would act. The maximum value of the applied force to which the block remains at rest with respect to the surface is called limiting friction. So this is what we learned in last class, that the maximum value of the static friction is called limiting friction. So today we are beginning with the idea of kinetic friction. So what would happen if we go beyond limiting friction? The idea is that a motion would start happening. That is the relative motion between the bottom surface of the block and the ground would happen. And since this relative motion is happening, the objective of friction is to prevent this relative motion from happening. So it either prevents the tendency of relative motion, that is the case of static friction, or it tries to prevent the relative motion but it is unable to, which is the case of kinetic friction. That is it is trying to prevent relative motion. That is what we call kinetic friction is. So if I were to define what is kinetic friction, so kinetic friction is that force of friction when the surfaces or contact are having relative motion, they are sliding relative to each other, and the force of friction acts in a way to prevent that relative motion. So that is what kinetic friction is. So as the body would start moving, and when would it start moving? When I have exceeded this limiting friction. So beyond this limiting friction point, just after we have increased the value of F beyond this value of limiting friction, we experimentally observe that this value of friction, which is plotted on the y-axis, it falls slightly. A very slight fall happens, and then it becomes a constant value, which is the biggest difference between the static friction and kinetic friction. See, what we learned is that in static friction, when the friction is growing with the applied force, the value of static friction is a variable value. Unlike kinetic friction, once the motion starts happening, there is a slight bump, and the force of friction, it becomes constant. So because of which we are able to say that the value of kinetic friction is actually a constant value, which we name as mu k. Fk is equal to mu k into n. Again the same principle happens, that the force is proportional to the normal reaction applied on the block, and in this case the constant of proportionality is called mu k, that is called coefficient of kinetic friction. So these values are different values: static friction, coefficient of static friction, coefficient of kinetic friction. These are different constants usually, but in most of the questions, to simplify the amount of variables available to students, the value of mu k and mu s are given as same. But practically speaking, the value of mu k and mu s are different, and that's why we have taken their values to be different only. And as you can see from the experimental values also, the value of limiting friction is slightly above that of the value of kinetic friction, and because of which mu k is slightly lower. So this is what the job of kinetic friction is. Kinetic friction, it prevents the relative motion happening. When there is sliding happening, it would prevent its motion. Okay, so let us move ahead. Yep. So that is what we are given. Kinetic friction Fk is equal to Fk is equal to mu k into n. That is what we wrote. Coefficient of kinetic friction. So let us start with some examples. So a block is stationary, and we have to take G is equal to 10 meter per second square. The mass of the block is given as some 4 kg block. Or how much kg block? The mass is given as, yes, it is 4 kg, and the horizontal force acting on the block is 20 Newton. So how much frictional force is the table applying on the block if the block is stationary? So we are given that the block is stationary, right? If the block is stationary, it does not matter we have studied just kinetic friction. It is given that the block is stationary, so relative motion is not happening. Relative motion between what? The surface and the block. So since no relative motion is happening, static friction would be applied, and static friction would just be equal to the force which is being applied on the block, that is P. It is given to us that the system is at rest. So since the system is at rest, that means the applied force has to be equal to the force of static friction. So that means static friction force is equal to 20 newtons. So how much frictional force is the table applying on the blocks? That force is 20 newtons. So we have drawn normal reaction and mg also, so let us draw also that normal reaction and mg. And what is the coefficient of static friction? Can we find its values? So the limiting friction on the block, now we know that since the block is not moving for 20 newtons, right? So it is not moving than 20 newtons, that means that the force acting on the block, that is the static friction which can act on the block, that is Fs maximum, the maximum value of static friction. What value should this maximum value of static friction should be from? Now what the question is asking is that, okay, we know that the static friction is 20 Newton, but what is the coefficient of static friction? So to find the coefficient of static friction, we would have to think about limiting friction, and we know that the block is not moving for 20 Newton force, right? So that means that what should be the minimum value of static friction available for us? So the minimum value of static friction available for us is this 20 Newton, right? That means that the static friction value cannot go beneath this 20 Newton's force. It must be more than this 20 Newton's force, so that it is able to supply this force to keep it stop from moving. So we would say that the maximum value of the static friction which should be available to us should be more than this value, which is 20 Newton. That is what we want to what we are trying to say is that if the maximum value of static friction is, let's say, 20.1 Newton, if we are assuming that the maximum value of static friction is only 0.1 Newton greater than what is required, even then the block won't move. If it is 20.01 Newton, even then we can apply 20 Newtons. If it is 20.001 Newton, even then the maximum value of static friction won't have to go to that value, and only force required is 20 Newton to keep it from moving. So that means that if we go beyond go below 20 newtons, let's say the maximum value of static friction which we have is 19.9 newtons, then the block would definitely slip, and this case won't happen. So for this case to happen, the minimum value of the maximum value of static friction has to be more than the 20 newton value, and the maximum value of static friction is called mu Sn is greater than 20 newtons, and we are given that the mass of the block is 4 kg. So that means normal force acting on the block is 4 into 10, that is 40 newtons. So that means that coefficient of static friction into 40 should be greater than equal to 20, or mu s should be greater than equal to 0.5. Okay, so this is the first example. Now let us take one more question. So then we have a block of mass 2 kg and action to gravity is some 10 meter per second square. The mass m is hanging from this 2 kg block and coefficient of friction is 0.2. What should be the maximum value of m so that the blocks stay at rest? So we have a pulley system and this mass is some 2 kg mass. This is connected to the block of mass m. So we are supposed to find what is the maximum value of m, small m, so that the system remains at rest. So when we are talking about maximum values of m, that means that we would be talking about maximum value of friction happening at this point, right? Since what is going to drive the system in the downward direction or rightward direction? The system is going to be driven, or the blocks are going to be set in motion by this gravitational force, by the gravitational force of the mass mg, and it would generate a tension which would indirectly try to move the mass 2 kg. And what is going to oppose that particular motion? What is going to oppose that particular motion is the tangential or is the frictional force. So the force of friction which is going to oppose this gravitational force or gravitational force mg, that value is mu s, right? And what is the maximum value of friction available to us? The maximum value of friction which is available to us, fs maximum, that value is usually mu Sn, limiting friction, and we know what is the value of mu s, that is 0.2. The normal force which we have is 2 kg into 10, that is 20 newtons. So this would become 4 newtons. So that means that the force which is available to us to prevent the motion of the whole system, that force is 4 newton. We cannot apply force more than 4 newton, right? That means that if the tension in the string exceeds 4 newton, the block would start moving, right? We should think in this way, that the static friction acting on the block is having a maximum of 4 newton. That means tension exceeds 4 newton, motion will happen. We have to prevent a motion. That means that the maximum value of tension can be 4 newton. That means the maximum value of tension here can be 4 newtons. That means the maximum value of gravitational force which can be applied on this block has to be equal to 4 newton. So this means that the maximum value of the mass mg is equal to 4, or let's say the maximum value of mass which we can hang from this particular string so that the blocks remain at rest is 0.4 kg. If the masses are below that, then the system won't move. Static friction would won't have to act at its maximum value to balance this force. And if the value of m goes beyond this, then definitely motion will happen. So let us take this particular case. We have to find the maximum value of F for which small m and capital M move together. So these kinds of questions, again we have to grind down a little bit to learn about these questions. So what we have learned so far in the previous questions, if we'll take a recap. In the previous questions, what we have learned is that we usually first evaluate what is the maximum value of static friction acting at the surface. In the example also we did that, what is the maximum value of static friction, and then we worked around that particular value, that what value should maximum value of static friction should be more than. So it has to be more than 20 newtons, so we did the question in that way. Again, in our question which we did, what we did was that we calculated the value of friction which can act on the block kept on the surface, and we said that okay, this value is available to us, this value can be applied by the string, and this value can be used to balance the mass of the block mg. So that means that calculating mu/sn, it helps us in, or thinking about the value of mu/sn, it helps us in thinking about these questions. So here the question is that what maximum value of force can be applied on this lower block of mass m which I have shaded, so that the motion does not happen between small m and capital M. The surface between small m and capital M is having some coefficient friction mu, and the surface beneath them is smooth. So how to do this one, how to approach these questions? So to take the approach to these questions, what we start with is a very simple idea that we first assume that the masses capital M and small m are not sliding with respect to each other, right? Even if they were to slide with respect to each other, we'll take that case in the second point. First point which we are going to consider is that let's assume that capital M and small m are not moving at all, and let us evaluate that case. So it gives us some understanding at what is going to happen in this particular question. Like what is asked in this question is that find the maximum value of F for which small m and capital M is moved together. So this is what we have assumed. So that is helping us, but let us see how. So we have assumed that small m and capital M are not moving with respect to each other, which means that the force of friction would be a static friction, right? So this is the first point which is important to us, that we decided what kind of friction is happening in the between the two surfaces, surface number 1 and surface number 2. Now beyond that point, what we will do is that we are supposed to find the maximum value of F, right? What is the maximum value of F for which motion is happening? So when we're talking about maximum value of F, this whole system is having the external force F only, since the surface beneath them is smooth. So when the force is maximum, the acceleration would be maximum. And let us observe the mass small m. We will directly go to the point. Let us observe the mass small m. Now we are talking about maximum accelerations, right? As the force is maximum, that means acceleration of small m, capital M mass would be very high also. And to produce maximum acceleration, we would require very high values of friction. So we would require very high values of friction. That means that this value of friction which is provided by the block beneath the mass small m on the block above it has to be in forward direction. So first we have to think about in which direction the friction is going to be happening. So it's going to be a static friction force since motion is not happening between the blocks. Second, this force is going to be happening in forward direction. And why is that? It is because of the fact that capital M is going to slide beneath the block small m mass, and it wants to prevent relative motion between small m mass and capital M mass. So it would prevent small m mass from falling behind the capital M mass, and in turn it would apply a force of friction on the small m mass in forward direction, and so as to ensure that there is no relative motion between small m and capital M mass. And the second reasoning can be, okay, the system is going to be moving in horizontal direction, right? So which force is going to be applying acceleration in rightward direction? Normal reaction won't create acceleration. Gravitational force cannot create acceleration. The only force which can create acceleration is the force of friction. So that's why it happens in forward direction. The normal reaction on this block is some n, let's say its value is some n, and the gravitational force is some small mg. So the maximum value of static friction which can act on the block above it would be having the same value which we have calculated earlier. The maximum value of static friction is mu s into normal reaction, which is mg. So it's a mu mg is the maximum value of friction which can act on the block, and maximum value of friction would be required to produce the maximum acceleration. So the acceleration of the block would be the force which is applied in horizontal direction, that is the force of friction mu mg, divided by the mass of the block. So that would give us the value mu g. So this is the maximum acceleration which we can conceive for this particular system. Now let us consider the whole system as one. This whole system as one block system. So for this whole system, what is the external force acting on it? The external force acting is F. So we'd say that the whole system would be having mass capital M plus small m, and its acceleration would be the value A max, since the blocks are not sliding relative to each other. So we'd say the applied force F is equal to capital F equal to capital M plus small m, and that would be A max because not only the upper block, the lower block would also be having the same acceleration A. So the maximum value of acceleration which we have calculated is mu g. So this gives us the value which we are looking for, that what is the maximum value which can be applied on this lower block so that the blocks move with each other, move together. So this would be end for this particular video, which contain mainly examples of static friction and what are the beginning ideas of the kinetic friction. In the next video, we'll be doing with more questions of kinetic friction and static friction. So thank you for joining and have a nice day.